Hey everyone, welcome to another video. Today we're going to be looking at signals in Dart. It's a really nice pattern for state management. I've just been getting into it myself and I figured I'd show everyone who follows me what I've learned and how we can work with it. So we're just going to build this really simple app, well, kind of like three sub-apps that grow in complexity. The first one is a very basic counter app. Looks very much like the counter app built into the example package when you start a Flutter project, but it is using signals instead of a stateful component. And you can see we can increment the numbers. Super exciting, I know. Then we're going to go in and just build something a little bit more complex, a to-do app. So something where you can check off various things. You can add new tasks. And you can even filter by whether they're active still or completed. And then lastly, we're going to work with HTTP, doing an API call, really simple API call, but enough to kind of see how we can deal with the different states of a future, when there's an error or when it's loading. And we're just going to have this simple little jokes API that we hit to get us back some data. So pretty basic stuff, but I think this will cover a lot of the use cases of what you use a signal for. I definitely recommend checking out the docs. The links will be in the description. So let's get into it. All right, so I've just initialized a fresh Flutter application. And I've just kind of set up some very basic boilerplate so we're not wasting time on making screens. So I have a home screen and it basically just has a list of the different screens you want to go to. And I've just created these screens. They don't have anything with signals yet. They are just basically empty scaffolds, just so we don't have to worry about doing that in the tutorial. I've also, in the main.dart, set home screen as the home. I've turned off the debug show checked banner, and I've just done a little bit of analysis options by turning off const constructors and literals. If you've seen videos before, I usually do that when I'm sort of initially building something because it really gets in the way, and then I'll enable it later to actually clean stuff up when I have stuff working. So that's basically all we have. And then I've also installed just two packages. We're just going to use signals, which is the topic of this video. And we're also going to just install the HTTP library. You're welcome to, of course, use DO or whatever your preference is. But this one's really simple, and it's all we really need to call our little API later in this series. So let's get to it. So we're just going to start with the counter screen, which again, I've just mocked up like this, and it's very basic, nothing going on yet. The first thing we're going to want to do is import the signals package. So signals Flutter, and now we can create our counter. Now, for the purpose of this tutorial, I'm going to be putting everything in the same file just so it's clean and simple. We're not wasting time making files and importing it in things, but these can of course live in their own files, no problem. But we're just going to do this here. We're going to create something called our counter, and it's just going to be a signal, and this is just part of our signals Flutter, and we're just going to set its sort of initial state. And it's smart enough to know if this is passed in that this is going to be a signal of type int, just because of what's in here. We can define it by just passing this here. That way, if I actually put a string in here, you'll actually see there's an error, saying like string can't be assigned to int. So it's a good practice to put what type of signal it is. So we're going to do that, and that's its initial value. And then we're going to just create the body of this, and let's just put this in a center. And this is ripped, pretty much right out of the example package when you first install this. And we'll just do our main axis alignment of main axis alignment.center. And we'll give it some children. And here we'll have a text. And this will be our lovely, you push this button, how many times. So we'll just put that in there. And after this, we're going to want text that's actually going to have our counter. And let's make this, look really good by giving it theme of context, text theme, and we'll use headline medium for this. So if we save that, we'll actually see this here. Now there's no way to interact with this, and this is actually just hard-coded. So let's make it interactive. Following, the basic example, we'll just put a floating action button, and it's going to be obviously a floating action button. And here we can have a child of an icon, and let's just use icons.add, and we should now have a little guy in the bottom right there if I remember to put the onPressed event, which is a required field. And there we have it right there. It doesn't do anything yet. So there's two things we want to do here. One of them is obviously incrementing this value. So let's figure out that first. And it's actually really easy with signals. All we have to do is go counter dot value. So we want to talk to its value and just go plus plus. That will just increment it. Then down in here, we obviously want this to change. Now there's many ways to sort of watch for the state. One of the simplest ways is we can actually just go counter dot watch and pass in the context, which is just required when we're doing this. And this will now watch that value. So if I actually save now and go, we are good. Now there's a few other ways to do this, and we'll get into that in future ones, but there's our basic counter app. So we're not using a stateful component here. We just have this counter, and it's automatically rebuilding this when something in the counter changes. So there you go, very basic signal. Let's get to a little more complex use case here. We're going to go to our to-do screen, and we'll go to it over here as well. Again, it's just empty, and we are going to get working on this. So again, I'm going to put this all in the same file. You know, you might want to break this into like models and providers and services and whatever else you might need. But for the case of this, we're going to do it this way. And we're also just going to use a type def for the model, if you want to call it that, rather than making, a model in something like freezed or even just, as a class. This is just a nice way to deal with data and records. So we can go type def, and we'll call it a to-do, and we can set what different properties it will have. So it's going to have a string called label, and it's going to have a bool called completed. And that's basically just our data structure for what we're calling a to-do. And I actually have to remember to go equals this. So we're setting it to a record like this with that shape to it. Then we're also going to make something that's just like our initial state when we load up the application, just so we don't have to, every time we refresh, have to retype things. So we're just going to make a final list of to-dos, and we'll call it initial state. And it's just going to be a list of some things. So the first one might be a label. See, we get the nice IntelliSense because we're using this. Label of read docs. And it's completed. Yeah, we'll say, yeah, we've read the docs already. Cool. Then we might have something like, okay, now we got to write code. Well, we haven't completed that yet. And we might have one called ship it, and also not completed. So we have a bit of an initial state. Then what we want to do is actually get our signals working. So we'll import in the signals package again, signals Flutter. So even though it's called signals Flutter, it's part of the signals package, the Flutter implementation of it. So you are still importing signals, and specifically we're going to be using the Flutter implementation of it, which comes with some extra stuff like the watching and everything to do with the widget tree. So let's make a list of our, or make our signal, and we'll call our signal to-dos, and we can actually say what it is, and we want to basically pass in our initial state here. Initial, I don't know why it's not, oh, because I need to have an equal sign here. So our to-dos is going to be equal to that. We're going to initialize it with our initial state, and we're going to convert it to a signal. So we're basically just taking a list of things and making it a signal. So now you'll see this is a list signal, which is a type of signal offered in this package. And so that gets us our list of to-dos. So that's kind of cool. Let's get into actually listing these on the screen. So we'll start by in our body. And what we're going to do is we're going to wrap our body in a builder. And this is a builder called Watch Builder. And it works just like a builder, except anything in here will be able to update when things change. So if you've used Riverpod before, this is kind of like wrapping something in a consumer. And this will allow us to work with the values instead of having to watch each one individually like we did in the counter here, where we actually said, counter.watch. Anything within here will automatically rebuild when the signal is updated. And in here, we're going to, let's return a list view dot builder. And here in our item builder, we're going to want to do some stuff in a minute. So let's just pass in context and index, and we'll return, just for now, just a size box. But we also want to make sure we know how many items will be in this. So of course, an item count, and we'll just take our to-dos to-dos.length we can do here. So that'll be the length of them. And here we'll actually, have something that represents that to-do. So let's actually start by just putting text. And what I like to do inside these is actually make a reference to the to-do by going to-dos and then index. We'll see that this is now this record following that shape. And we can basically just, for now, just put in to-do.label. So we save that. And I will just refresh. There we go. Oh, it actually did end up showing up. But yeah, we'll go here, we'll go back to here, whatever. We see our things in here, and that's just using the initial state. We haven't done anything to modify it yet, but it's being put in. So let's actually just make this a little bit prettier. We'll simply just have a card, and we'll have a child, which will have a list tile. And the list tile will have a title, which of course will just be the to-do.label. And we'll also have a trailing on here, and that's where we're going to have a checkbox so that we can check these things off. And this will require a value, and we can just use to-do.completed as its value. And it'll also need an onChange, which we will figure out later. So this should make this look a little bit prettier. And now we have this lovely thing, and when I click this, it doesn't do anything yet. So let's make that actually do something. So in this case right now, because this is a pretty simple list, we can actually very simply just go to-dos, index, so the index that we're looping in right now, and we can just update it. So what we need to do is actually set a new record here, but we'll use the existing label. So we'll just take to-do.label, but then we want to set completed equal to this value. Now the problem is in the checkbox, this can be null. I'm actually not sure why that's the case, how it can change and not be either true or false, but we can simply just wrap this in, if value does not equal null, just so we don't have a possible null value being passed in. If anyone knows why that's the case, it's, I've noticed it in a few different places. That would be great. Write it in the comments why, how this could ever be null. I'm sure there's a great reason. Okay, so now that we have this, if we click this, we'll actually see they change because we're updating the state of it. And the signal is listening and everything's going and it's great. Next, let's add the ability to create a new one. So here what we're going to do is we're going to use, again, a floating action button. So let's just get that in here, and we'll give it a, it'll have an on pressed event, which we'll do shortly. And let's just give it a child of an icon, and we'll use icons.add, similar to our counter one, because we're making a new one. So we got this guy here. Now what we need to do is actually just capture the value. Rather than typing this whole thing out, because this has nothing to do with signals, I'm just going to paste something in from my example project. And we'll make this async. And all this really is doing here, and let me just grab one other piece and I'll explain it. We're just going to create a text setting controller here, text setting controller. So we're showing a dialog, we're awaiting the result of it. And this dialog is pretty basic, and I'll save and actually just show. All it is new task, and then you can type in this. And there's a cancel button and an add button. And because we have a text setting controller pointing to that text field, in the add button, we can actually pop this alert dialog, which will finish this promise here that it's awaiting for, and it will, instead of just returning null, it will actually return the text within it. Versus if we put cancel, it'll return null. So nothing signal wise here. That's why I kind of just breezed over it. But the cool thing is now we have this label value, which could be a string or it could be null. So of course we want to check if label does not equal null. And we also want to check if it's empty, because we're not doing any form validation here. You of course could. So let's just make sure it's not empty before we do things. And then this is pretty obvious what we need to do here. We just go to our to-dos, and we can actually just do an add on it because it's just really a list at the end of the day. And here what we want to do is pass in a label, and we would use that label, right? The one that we typed out. And we'll set completed equal to false, because generally if you're adding a new to-do, you haven't completed it yet. And if you have, you probably want the satisfaction of clicking that button. So let's just try this out. So we ship it, and then profit is obviously the last step. and it's added in there and everything's great. So all of our stuff is working beautifully here. Okay, another cool aspect of signals is the ability to sort of like compute a value based on a given signal. So what we might want to do, for instance, is show how many are completed or how many are not completed, that kind of thing, and how many there are in total. So let's set those up. First of all, let's figure out the total. So what we can do is we can make something called to-do count, and it's going to be equal to something called computed. So computed is part of the signals library, and it's not specific to Flutter signals, it's just part of signals in Dart. And in here, we can actually return a value that's computed based on another signal. So here we would simply just return to-dos.length. So simple helper here. We might also want to, for instance, know how many are still active. So it's pretty basic, but we can just go make to-do active count, and I'm just going to actually copy this because it's pretty similar. The main difference is we want to go to-dos.where, and we'll call this to-do, and we want to say to-do.completed, but we want to know the ones that aren't completed. And then we'll just do a length on that. So that will return, the length of all the ones that are not completed. And I bet you can guess what we'll do here. We'll call this completed to-do count. And in this case, it's the same thing, except we get rid of the negating exclamation mark there. So now what we could do is in our list view, or actually before our list view. So what I'll do is I'll wrap our list view in a column. And then we're going to wrap the list view again in an expanded, because we want this to take up as much space as possible. And if we don't do this, we'll have an error because it won't know how much space to take up and all that fun layout sort of stuff. And before this, let's just put some text kind of explaining this. Now, this could obviously be done with a bunch of, you can make a row with really nice iconography. You could do whatever you want. But for the sake of this, let's just have a text field. And maybe we'll make it a little bit better by wrapping it in a bit of padding. But inside here, we're just going to do something like total. We'll just start with that. And we can actually take our to-do count dot value, and that will be the value returned from it. So if we do that, we should now see there's 4 to-dos in total. And of course, again, you can lay this out however you want, but I'm just going to do a /n, and I'll just copy in these ones because it's the same sort of thing. We're just going to have a new line, and then we're going to say active, and we're taking our active to-do count, and we'll have a new line for completed. So we have that, you have this, looks cool. Could look a little bit better, and could look a lot better, but we'll just start with doing a text line here, dot center, and we'll save that. So now we have this cool little, thing, and as we change stuff, because these are computed values, they will be affected by the signal. So we don't have to rerun something or watch something else. They are, derived. So you're seeing these things are getting updated without us really doing anything. So that's pretty cool. Lastly on this one, let's add the ability to filter. You might want to say, hey, I want to only see the ones that I've completed, and so on and so forth. So to do this, we're going to start by underneath here, we're going to make an enum. Again, just putting this all in the same file just to make it easy for the tutorial. But of course, break these up in a larger application into things that make sense to you. And we're going to allow something called all, active, and completed. Now, something I love doing with enums when it makes sense is enums are really powerful in, since Dart 3, I believe, where we can actually kind of add other aspects and properties to them, which just makes it easier to work with. So what I kind of want to do is on our filters actually have a label that represents all these. Because I don't want to, just convert this to a string. It'll be lowercase. It might look weird. So we can actually go final string label, and then we can do a const constructor on the filter enum and pass in this dot label, just as if this was a class. Now it's giving me these errors because it's expecting me to put something in, so I can actually put in the first parameter as the label that I want. And you'll see why this is helpful in a minute. So we have this enum representing our different filters, and what we're going to do is actually make a new signal called filter, and we just do signal. And here we'll pass in the default, and default will be filter.all. So there we have a signal. And again, we can, do this, which I do recommend doing, because then you actually get the IntelliSense on, what it is when we're using it later. So there we have a filter. Okay, so what we want to do is now do a computed version of this, because we want, we have our state for all of our filters, but we want, for all of our to-dos, but we want to be able to also be like, okay, just based on the current filters, show me that. So we're going to make something called filtered to-dos. And again, this will be just a computed value. And we will go here. And we can do, what I want to do is just kind of, what's our current filter set to? So we'll just say current filter is filter.value. So this will be, and you'll see with the IntelliSense, we'll see it's a type of filter. And then we also just want a sort of a reference to our current to-dos. Now this isn't necessary. You could do this in the logic that we're doing later, but this just makes it easy and clean of what it is. So those are all of our current, all of the to-dos, and this is our filter. Then what we'll do is we'll actually switch on the current filter. And what's fun is you can kind of go and, I wish it would do all three. I feel like it did at one point, but we can actually go and add these in just to get it ready. And in the case that we're doing R, really what we want to do is just return our current to-dos, right? And we'll want to convert this to a list. So there we have our list of to-dos. Now when we're active, it's going to be pretty similar. We're just going to do our, return our current to-dos, but we're going to want to go where, and this is similar to before. We'll call this to-do, and we want to say, where to-do dot completed is false. That's why I have that there. And for the last one here is, we just get rid of this. So nice thing with enums is we don't have to have like a default case, because it's always going to, we know it has to be one of these three, so we don't have to have a default, which is handy. Okay, so now we have our filters here, and we can do some cool things now. So first of all, let's build our little widget that's going to represent this. So I'm going to do that as an action button. So we can go in our app bar and actually do actions. And for this, we are going to just use a pop-up menu button. So I'm just going to go pop-up menu button. So this is just, a Flutter thing, nothing really to do with signals yet, but we will be integrating with it. So our item builder, we're going to want to return some things. And we also want a child on this so that we can kind of see what it is. So we can just go child text. Sorry, for now, I'm just so this isn't complaining, we're just going to return an empty list. But our child, what we can do is we can say filtering, and then we can actually take our filtering filter.watch. So this is the other way we can do it. And the reason I'm doing it here is we only really need this. And I could wrap this whole thing in a watcher builder, but because all we really care about is one thing, it kind of makes sense just to do the filter watch here. So we want to go here, and remember, this is a reference to a filter, and filters have this cool thing called label that we made. So we can actually go like this and go dot label right on the filter. So if we actually just save this now, we should see something up here. Now I'm going to put this in a bit of padding, and we'll just do it on just the right side. So it looks a little bit better. And now we need to actually have our drop down buttons here. Now, we could manually put these in, but it's going to be kind of repetitive because they're going to kind of be the same. So what we can actually do is just take our filter enum, and we can go .values, and that'll actually loop through all of them. And then we can map that, and we'll want to remember to convert this to a list at the very end. And inside the function, and we'll just call this filter, what we really want to return is a pop-up menu item. And this will have a child, and that will be text. And we can actually do the text of filter.label. And we're also going to want a value on it so that we can work with it. So let's put that before the child value. And here the value is just going to be the filter itself, which is the reference to that instance of the enum. So now we should actually see these here. So here they don't do anything yet, but we're looping through them. So how do we handle that? Well, on our pop-up menu button, we can also do an onSelected, and let's just call this value. And you'll see, because Flutter and VS Code is smart, it knows that this is going to be an instance of a filter. And simply, we can just take our filter signal and set its value. So filter.value is going to be equal to that value. So now, when I change this, this part's actually updating accordingly. But our values aren't. And we've already got most of the work out of the way for this, luckily. But basically what we want to do is, in our list now, instead of looking through our to-dos dot length and our building along our to-dos, we actually want to look at our filtered to-dos and take the value of it and get its length. Then for our to-do, instead of looking at our to-dos again, we're going to do filter to-dos dot value index, and that will get us with these things, updating a little bit better. So we have all right now, but if I change this to active, you'll see only the active ones show up. If I see completed, this is good. Now there's one little issue here. It'll be fine. Currently, it's fine. When I'm in all mode, I can click this and click this. But if I was in, for instance, active and tried to do this, you're going to see weird things are happening. And that's because we're just updating the to-dos at the index that we're in. So in order to solve this, we kind of need a way to still be able to update this to-dos, because we can't update the computed. We can't just see, oh, set the filter to-dos. So what I want to do is actually have a way that makes these all unique. So we're actually going to add an ID to our to-dos, and we'll just make it an int of ID. And here in our prefab data, we'll just start at 1. So think of this like a database record. And we'll just make sure these are all unique. 3, 2. Then we're going to have a couple other errors, right? So we have our place where we actually create the to-do. So here we need to add an ID. And what we can actually add is the to-dos to-do count dot length. To-do count plus 1. That way we are, we have to do to-do count dot value plus 1 when we add it. So that will just increment it to the next number, which is great. Then instead of this line, what we're actually going to want to do here is figure out, when we're filtering, what the actual index is of this one. So really what we can do here is we can just make something called I. So this will be separate from this index, because this index is based on what we're filtering on. We want to know in our entire list of to-dos what one we're really at. So we can look at our to-dos, and we can just go to-dos.indexWhere, and we'll just call this T. And we want to go where T.id is equal to this to-dos ID. So this will be a index we get back, and we want to make sure it is if I is greater or equal to 0, because if one's not found, which isn't going to actually happen in this simple application, but could in other applications, assuming it is above 0, because if it's not found, index where will return -1, just being like, hey, it's not found. Then what we can do is go to our to-dos and set I, and here we want to just again pass in the to-do dot index or dot ID. We want to take the current label and go to-do dot label, but the main thing we want to update is actually completed is still going to be that value that we did here. So let's just save this. I'm just going to do a full refresh here because we kind of changed some stuff with our state. And we'll go here and let's just make sure this works. So that still works, and let's filter by completed, or actually by active, and make sure that ship it works. So it went away, which kind of makes sense because we're filtering by active. And if we go back, we'll see it's actually checked off. And if we filter by completed and uncheck one, it should also go away, but again, should still be in our main list here. And let's just make sure adding a new one still works. And checking it off still works. Okay, so that's kind of our very basic to-do app. I know it's not the most exciting application in the world, but this is the kind of stuff you do when you make software, is updating state, and really the purpose of this video. So there you have it. Okay, one more, and actually the next one's a lot simpler, but it does introduce a new concept that I think is really important. So we're going to go to our HTTP screen. So assuming you're building an app that needs to talk to the internet, you're going to be dealing with network requests. And network requests are funny because, they don't always work the way that you want. Sometimes an error can come back because your internet's out, or the server's down that you're talking to, or a million other things could go wrong. So we want to be handling things like errors. We also, need to be dealing with asynchronous. So far, everything's been synchronous. We just, make a change and it happens. But a network call doesn't happen instantly. It has to, go and talk to something and come back. So we're going to figure out how to do stuff like that. So I'm going to import two things for this. We're going to have our HTTP package, which I installed, as well as obviously Signals Flutter again. And we're going to be working with this thing called, it's basically like just a jokes API. Everything will ring true that I'm doing here for any API you're working with, at least any like RESTful API. But this is just a free, easy to use API, and you just hit an endpoint and it sends you back JSON of a random joke. So what I kind of want to do here is actually just start by, I'm going to create a constant. And again, this is just for purpose of the tutorial. And basically this is the API we'll be hitting. I specifically want to get programming jokes. I want these ones that are called two-part jokes, which have like, it's kind of like a knock-knock joke or something where there's like a call and response kind of thing. And I'm also blacklisting just some flags. I don't want this YouTube video to have something, political or not safe for work or sexist or anything like that. So that's just things they offer in the API. So nothing fancy happening there. It's just an endpoint I can hit. And actually, if we hit this now, you'll actually see we get back, and I can refresh this multiple times to get different ones. But we got a setup and we got a delivery because it's this two-part sort of joke. As well as some other data that we could work with if we wanted to, but we don't really care for this. Okay, so we have that API set up. Now, what we're going to be doing here is, first of all, let's create our sort of like type def, which is, kind of like our easy way to make a model. And we'll just call it joke. And all we care about, again, is like the setup and the string of delivery. And what we're going to do is make what's called an async signal. So I'm just going to call this S. And we want to use something called async signal, which is built into the Signals Flutter package. Actually, it's just in Signals itself. But importing this will give you that as well. And what we want to do is what is the type of data this could have. And it is going to be of type joke, but we're actually going to allow it to be null because initially there's actually not going to be any data, right, if you haven't made the API call yet. And here we'll set our initial state, and we'll start with async data. Like as if we have data, but we have to do async state dot data, and here I'll pass in null. So I'm kind of saying we're starting with, we're starting in a state as if we have data, but the data happens to be null. So there's three different main states here. We have async state, oh, I went to caps lock somehow. Async state. Okay, I can't type. Async state dot. Actually, I don't think I can even do this here. I just want to kind of show the different options. So we have async state.data, which is when there is data, async state.error, when an error happened, or loading for loading. So this signal is actually going to be a representation of that using wrapped in sort of this state. So we're not actually tracking the joke itself. We're kind of tracking it with a wrapper around it of, the different states that that data can be in. Either, an error, or there is data, or it's loading. So we have that. Now, what we will do in our scaffold here is let's just get a simple body, and we'll just use a column. And it's going to have some children, and we'll start by just having an icon button. Oh, I don't know why that auto-completed. Icon button, and we'll do an onPressed event, which we'll get to in a minute. And for our icon, we will just put a icons refresh, just so we can get a lovely little refresh icon right here. So we have it there. Now I'm going to also make this, main axis size min, and we'll actually wrap this in a center tag. So then we actually kind of have something, right in the middle here. This isn't doing anything, but we'll get there. So yeah, let's make it do something. So we're going to make a new function, and again, I'm just putting this in the same file. It's not even really part of this widget. You could, this ideally you would put somewhere else to keep things organized and separate your logic, but this is what we're doing today. So this is going to be a function that doesn't actually return anything because I just want this to actually be, working with the signal and updating it. So we're going to not actually return anything, but it is a future, and we're going to get joke, and it will be asynchronous. So the first thing we want to do when we get a joke is actually say, hey, we're going into the loading state. So we can just do that by going s.value equals async state dot loading. Now there is a quicker way of doing this. You can actually just go s.value equals async loading, and this is just a shorthand version of that. They ultimately are the same thing. I like this a little bit more. It just kind of feels like I see, okay, it's an async state, and this is the the state of it. But feel free to do it either way. There's the same for error, and there's the same for data. So we're going to wrap this whole network request in a try catch, because in the case that there is an error, and also we get a stack trace when we have an error, we can actually take our s.value and just make it equal to async state dot error and pass in that error there and pass in that stack trace. So we definitely, now we're kind of handling just an unexpected error happened. Then in here, what we're going to want to do, and I'm just going to copy this in because it has nothing to do with signals, and we'll import in our JSON decode function. But here we're going to use the HTTP library, and we're just going to do a GET request on this URL here. And we will get this, and it will do a JSON decode, and everything's great. Now in our API, based on kind of what I quickly showed right here, there is a field called error, which can be true or false. So what we can actually do right when we get our data back is go if data error equals true. In this case, we can kind of take this same sort of thing here and actually just set this and return short circuit out of here. And here, we don't necessarily know what the error is. Based on their API docs, we could probably find a way to, they might give you an error and we could actually pass that in. And we'll just pass null for the stack trace because we don't have one. But here we've, handled, at least the API saying there's an error, which is great. And assuming we get past this, we know there wasn't an error. So we can actually go final, and we'll just make something called a joke. And we're just going to set its setup to data setup and set its delivery to data delivery. And right here, we would just do s.value equals async state dot data and actually pass in the data that we want. And the data we want is this joke itself. Okay, so we're handling error, we're handling loading, and obviously when we change these, the loading will go away because we're updating, this signal's value at that time. Okay, now we just need a way to display this. So what we're going to do down here is we have our icon button, but underneath that, let's actually put in a watch.builder again. So we've done this once before, and here we'll have context, and we're going to want to do things. So the first thing is we can go if s.value.isLoading. We can actually just return a circular progress indicator, and I'll put it in a center. So we know it's loading, cool. And let's actually just return something temporarily just to show that in action. We also need to remember, because this won't work, we need to call that getJoke function here. So now if I click this, we'll actually see that centered loader as it's loading. Great. Then what we can do after we know, okay, it's not loading, cool. Let's go s.value.hasError. And here, we might do something similar, but instead of a loading thing, we actually do a center of text, and we take that error and convert it to a string. Now, in best practice, that's probably going to look ugly to an end user because it's going to be something like, like some Dart error. Ideally, you would find ways to make the error a little more user-friendly, but for purposes of this is fine. So let's see if we can trigger that. Right now, we're just getting back this ... which means really everything went fine. But let's, maybe change this URL to something else. Assuming they don't have a v3, we should actually see, client exception. Again, that's what I'm saying. This is not a great error thing, you would probably want to, either put something just like a generic error, or, kind of use the type of error to actually, set this dynamically to a better string. But it works for now. So let me just change that back before I forget, back to v2. And if we hit it again, we should be good. Then what we want to check also is if s.value equals null, because remember, it could technically, oh yes, okay. What we actually want to do, so now we know it isn't loading and it has an error. Now we want to actually get a reference to the joke. So the joke, we actually go s.value, and this is a little bit confusing. It's value.value, because this is the value of like the async state, and this is actually the value within that async state. And so we have that. Now technically, because we've set it up to allow null, we should probably check if joke equals null. Maybe we just return just something generic like text. I'll just do like error. I don't think there's a way for this really to happen in this particular setup, because we've kind of already handled like whether there's an error or not, but you never know. So if for some reason it's null, we'll just have error. And actually, we probably don't even want that, because technically when we start this application, if I was to restart, it's not really an error, right? It just hasn't loaded anything yet. So what we could do, so I'll just show you what I mean. Right here, we're actually going to see error because we've started as a null state. So this is kind of really like our initial state. So we could do something like, tap the button to load a joke. In a real application, you'd probably do something where when you land on this page, you're already calling the get joke and it would already be in a loading state, but that's beyond the scope of what we're trying to do here. And there we have that. Finally, we can very easily just return some, text. So here we're just going to return text. We're going to take the joke.setup. We know it's not null, and we're going to put a couple new lines and do the delivery, and we'll just wrap that in center. And here we go. Why are modern programming languages so materialistic? Because they're object-oriented. Great joke. And you can, keep tapping this for days and have a chuckle. Okay, so that's what I wanted to cover in this. This is a quick review. We did a very basic app of just working with an int-based signal to increment, which you can't do a tutorial without starting with that. And similarly, we did a to-dos application where we're allowing filtering and all this kind of stuff. And in here, we're using a list signal right here. It's a list signal, which is great. And we also got into doing computed values. And then in our last one, which went by pretty quick, but I think it covered a pretty important topic, which is asynchronous data, something you're going to be doing a lot in most apps. Definitely, check out the docs. There's a lot more types of signals. There's things for maps. There's things for futures. There's all this great stuff. I think it's a really cool library. I'm, looking into, possibly using this on a real project soon. And, I think in doing that, I'll also figure out what is the best way really to like organize, a project using signals in terms of, file structure and providers and services and singletons and all that kind of stuff. So hopefully there'll be another video on this topic again when I'm a little more, using it in the real world instead of just building really basic applications. All right, thanks for watching and have a great day.